Hi. Today, we're going to talk about the economics of the environment. First, we'll have Professor Stephen Smith introduce the basics of environmental economics.
Hello, my name is Stephen Smith and I've written Environmental Economics, a very short introduction. Here are 10 things you should know about environmental economics. First, left to its own devices, a free market economy will not deliver the level of environmental quality that people want. Firms can pollute, consumers can make choices without concern for the environmental consequences, and what we need is some level of environmental regulation, some level of government intervention to ensure that those decisions take account of the interests of the rest of society. Second, environmental economics is about this necessary intervention in the workings of the economy. It's about how much environmental quality do we want and what's the best way of getting it. Third, environmental economics is not a dogma. It's a framework for thinking about the fundamental choices and trade-offs in environmental policy, for weighing up the advantages and disadvantages of different courses of action. It can be used quite flexibly to think about a range of different issues in environmental policy. Environmental problems at the local scale, local industrial pollution, for example, right through to the major problems of global climate change. Fourth, eliminating pollution entirely is unlikely to be feasible, or indeed unlikely to be desirable. What environmental economics helps us to do is think about the costs and benefits, the advantages and disadvantages of more or less environmental protection. Fifth, environmental economists are sceptical about conventional legal approaches to environmental regulation. The so-called command and control approach to environmental regulation, based on detailed legal instructions, can tend to be inflexible and excessively costly. Sixth, market mechanisms which use prices or taxes to discourage pollution are more flexible and can achieve reductions in pollution at lower cost. 7. Emissions trading, systems like the European emissions trading system for carbon dioxide, reduce pollution by setting a firm cap on emissions and allow flexibility by allowing firms to trade. Firms that have high costs of reducing emissions can buy permits from firms that are able to achieve emissions reductions more cheaply. And in this way, the system reduces the overall economic cost of achieving a given environmental outcome. 8. A lot of research in environmental economics is about trying to assess people's concerns about the environment in the broadest possible way. Because environmental economics is not simply about the costs and benefits that figure in company accounts or things that cost money in the economy. It involves a much broader view of social value and of environmental benefit. 9. Tackling climate change will need coordinated international action. It's a global problem affected by the global concentration of carbon dioxide in the atmosphere, and individual countries acting alone can make only a very small impact on the overall problem, but would incur significant costs from any action that they take. A real meaningful international deal on climate change is the only way in which we're likely to make significant progress. 10. Tackling climate change will require major changes in the way that our economy produces and uses energy, and in the decisions of firms and individuals about production and consumption. The economist's argument is that these major changes spread across all of society will be achieved at much lower economic cost and much more effectively with less disruption to the way in which we produce and consume than if we tried to achieve the same outcomes through detailed legal prescription about how people behave.
The environment and the economy are deeply intertwined, meaning to limit harmful damage done to the environment, different people and groups have to cooperate. The main idea is to treat the environment like a common good, where it is everybody's interest to help maintain it. This would mean discouraging public bads, which are things that end in a negative result for everybody, like air pollution, and encouraging positive environmental spillover, where positive actions to help the environment would spur more positive action. It's also important for different markets to realize any possible negative external effects, which are when production negatively impacts a third party. For example, irrigation runoff from agriculture can contain pesticides that would severely affect the market of a fishery that relies on the now poisoned river. Possible ways to combat these are to set bonus taxes and/or quotas on environmentally damaging products and practices, and possibly even bans, such as on toxic chemicals like CFCs. The main way we damage the environment is through greenhouse gas emissions from industry. Greenhouse gases are gases in the atmosphere that contribute to the greenhouse effect by absorbing radiation. Examples include carbon dioxide, methane, and water vapor. The current problem is that greenhouse gas emissions, especially that of carbon dioxide, have reached a dangerous level. Merely stabilizing emissions wouldn't fix the problem, because these gases remain in the atmosphere for a very long time, and the damage will only continue to increase as the gases stack up. A limit of 1 to 1.5 trillion tons of CO2 can be emitted in order to maintain a temperature increase of 2 degrees Celsius above pre-industrial levels, with reaching 3.4 degrees Celsius drastically increasing the chance for catastrophe around 10%. A major source of greenhouse gases, fossil fuels, is also not stable for the economy since reserves are limited. This graph here shows the temperature and atmospheric CO2 increase over the past centuries, and you can see that they reach extremely high levels exponentially past the Industrial Revolution. The temperature increase and CO2 levels are also shown to be highly correlated. One way to tackle the problems of the environment is through abatement policies, policies that reduce environmental damage. Methods include using new, more efficient energy technologies, and the banning or reduction of environmentally damaging goods and practices. However, these abatement policies will always have trade-offs, since helping to preserve the environment usually results in a more negative impact on the economy. They require cooperation and will always remain a divisive issue. This first graph shows the global greenhouse gas abatement cost curve, which shows the abatement potential of greenhouse gases using different abatement methods, ranked from the lowest to the highest cost. These next two graphs show how implementing abatement policies can have different effects and efficiencies based on how they are implemented. In the graph to the left, the least cost abatement curve is shown, where the lowest cost changes are implemented first. In the graph to the right, the highest cost changes are implemented first. The difference can be clearly seen, where the former is far more efficient and the potential of each practice is fully exhausted. The first graph is able to reach around 11.2 gigatons of CO2 reduced, while the second graph only reaches around 4.94 gigatons of CO2 for the same cost. In this graph, the relationship between the quality of the environment and the consumption of goods and services is shown, where one has to be sacrificed for the other to be better. The feasible set is the areas where one part can be sacrificed to an efficient enough extent. The MRT, or marginal rate of transformation, shows how an increase in environmental quality would lead to an increase in consumption, and vice versa. The MRS, or marginal rate of substitution, shows the indifference curve. A steeper curve happens when a higher value is placed on cost and or a lower value is placed on the environment. And a less steep curve happens if more value is placed on the environment and less on the consumption. In this graph, though, the indifference curve is assumed to be linear. The point X on the graph is when the MRT and MRS are equal on the feasible frontier, the most even level of abatement policy. The point B shows another possible level of abatement policy implemented, if they cared less about the environment and more about cost and consumption.
And so we move on to bargaining wages, pollution, and jobs. Balance is important between the workers' wages and the environment, as these are potential factors that can shift people toward two different directions. Both sides of the workers and employer have their own respective situations of bargaining power. A slight disclaimer is that these bargaining powers only exist in certain extreme situations, and so workers will have the ability to leave for a different job opportunity if their current job is not the main source of employment. The employer, on the other hand, has the ability to control their wages, in the case where they are virtually the only source of employment and income in the area. As well as the aforementioned reasonings, bargaining power can be affected as a multitude of separate factors. such as a limit to enforcing emission rates, not enough communication with the workers about the work conditions, the consensus of the citizens, lobbying, and legal recourse of their emission levels. And so you can see with this graph, the bare minimum of retaining workers is illustrated by the red graph, with the blue graph indicating the limit of the business before they become bankrupt. The E of max is indicated on the upper graph, which illustrates the case where the workers are able to stretch their bargaining power for a better environment at a set wage. On the other hand, E min, which is indicated on the lower graph, represents a situation where the company is in control and is at the lowest point where they can set the environmental quality before causing workers to leave. And so point C is where the two extremes come to the middle for the environmental quality, which is called the Pareto effect. And these here are the equations for the graphs above, for the graphs in the previous slide. And so now we move on to cap and trade, which is a policy that combines a legal limit to emissions with an incentivized-based approach to give abatements required to meet a legal limit among firms and other actors. And so there are two types of policies: price-based policies and quantity-based policies, where a price-based policy is a policy that uses a tax or subsidy to affect prices with the goal of internalizing the external effects on the environment of an individual's choices. And quantity-based policies are policies that implement environmental obstacles by using bans, caps, and/or regulations. So this is a mini crash course to cap and trade, where basically it starts off with the government setting the caps to control the quantities inside the policy. Then the government creates permits to limit the total amount of emissions to the size of the cap. The government then distributes the permits to firms emitting pollutants or permits that they can also be auctioned off to polluting firms by the government. Permits are traded between other firms due to the excess being produced from firms that produce little to no pollution. The firms then submit their permits to the government to cover the emission records. And so this graph shows the gains from the trade created by the marketing of permits. P is the permit price and is equal to the marginal cost of abatement in the economy. The green area above the red dashed line is a share of the gains from trade that firm B receives, while the area below is firm A's share of the gains from the trade. And so now for measurement of economic policy, there are two ways, or rather techniques. There's hedonic pricing and contingent valuation. Hedonic pricing is a method basically used to infer the economic value of unpriced environmental or perceptual qualities that affects the price of a market good, while contingent valuation is a survey-based technique used to assess the value of non-market resources. And so hedonic pricing is basically review preference, and it's usually based on how people feel and the way, like their behavior and how it will affect the economy that way. For example, housing, in where it would be based on where they want to live, or the environment around them would influence what type of house they would buy. Contingent valuation is basically self-explanatory, where it's based on surveys and statements itself, not based on like actions that they perform. And it's much easier to collect data. And so overall hedonic pricing and contingent valuation paved the way to measure how people value particular changes to the environment, while contingent valuation relies on people's feelings to particularly changes in the environment. While contingent valuation relies on the people's feelings through surveys, hedonic pricing is influenced by the psychological aspect of human behavior.
As technology continues to evolve, the feasible set, all constraints within an economic model, enlarges. Other improvements can make abatement, the reduction of environmental damages, more efficient, which in turn lowers the opportunity cost, which is the cost of picking one option over another. In turn, technology helps improve the marginal productivity of abatement expenditure. This essentially means that technology can lower abatement costs while also still improving environmental quality. Due to innovation rents driving progress, if the right motives arise to create innovation rents, then there would be many more technological breakthroughs. One example of this is solar energy. Subsidies to companies creating solar energy related equipment and those that install them have led to more research and development being done. Not only that, demand has increased, which lessened its price due to companies improving their production line. Unfortunately, renewable energy like solar and wind can only be utilized within certain conditions, making fossil fuels preferred in the absence of subsidies. On the other hand, imposing a tax can create innovation rents by changing the prices of certain things to promote innovation. In a hypothetical situation where the company producing energy turned to coal as it was the best cost minimizing strategy, if a tax were to be put on carbon-based energy, the company would instead turn to developing and innovating something like solar energy, as it would now be saving them money. Aside from policy changes, changes in the environment can occur through means such as the desire to contribute and even certain lifestyle changes. An example can be seen in a public goods game conducted with shrimpers in Brazil. Shrimpers had a choice of cutting big or small holes in their traps to let immature shrimp go. This either increased their profits by hurting the environment and other shrimpers, or lowered their profits but helped the environment. In the experiment, those with greater patience and cooperativeness cut bigger holes, which helped protect future stock. As for lifestyle changes in the Netherlands, workers had much longer hours in the 20th century than in the 21st century, yet the adverse effects on the environment were worse back then. This is because working longer hours led to using more money on consumption, like traveling, which in turn produced more CO2 emissions. Had nothing been done to decrease work hours and increase free time, the world would be in a much worse place than it is now. Even before human intervention, the natural environment of the Earth had been constantly changing with events such as the Ice Age. Nowadays, climate change has been heavily influenced by people and thus created a precarious situation. This is in part due to the environment's own changing dynamic. To understand this, one must talk about equilibrium. Equilibrium is defined as a self-perpetuating system in which the model does not change until some external factor is introduced. As such, in economics, equilibrium can be both good and bad, as shown in some systems, like the Arctic sea ice, which has seen a decline over the last few decades, as shown in the graph to the left. This is due to global climate change negatively affecting previously healthy ecosystems. To go more in depth about the Arctic sea ice example, two things can happen: positive or negative feedback. In this example, a negative feedback effect would occur if there was enough sea ice so that variations in temperature and the reduction of ice wouldn't affect the sea ice enough. As such, the system would maintain equilibrium by always going back to a certain level. On the other hand, a tipping point could arise if several hot years greatly affected the system and reduced the ice to a significant extent. This in turn would lessen the ice in subsequent years and lead to a positive feedback effect to bring the system's ability to recover ice to its breaking point. Because of that, bringing attention to tipping points of systems has become a hot topic for environmental scientists, and for good reason. So what does climate change have to do with equilibrium or tipping points? Because of warming climate, for Arctic sea ice, the climate starting at a higher temperature brings the good and bad equilibriums closer together, effectively making the tipping point easier to break. One small shock could bring the system into a danger zone. With all that in mind, it's important that people make more effort to solve this global warming issue, as the number of factors affecting the tipping point of systems is impossible to fully predict. Now, even with all the evidence that climate change is not only real, but hurting ecosystems over time, not everyone is on board with dealing with it. This is in part because there is still so much that we don't know about how climate change occurs and plans we can potentially take to truly stop it. Another reason is simply that nations don't seek to solve it, as it wouldn't be the most effective choice for them. However, if nations, for example like the US and China, could be more mindful of each other and be willing to take more costly measures as long as the others do too, then the restriction of carbon emissions for both nations could be possible, therefore reducing climate change. Unfortunately, this ideal is easier said than done, with one main factor being that future generations are being unrepresented in policymaking regarding these issues. The only times these unrepresented groups are talked about is when people are considering the ethics of the situation. This valuing of future generations can be called the rate at which we discount future generations' costs or benefits.
Lastly, we have the impact of environmental policies. Here, the graph illustrates a pretty strong positive correlation between GDP per capita of a country and its environmental performance score. However, countries, even at similar levels of income per capita, differ greatly in their environmental performance. Of course, a country's wealth is not the only factor in determining environmental performance, and economists believe that the differences between performance are largely due to kinds of policies that are adopted and enforced by the country. So, we have win-win policies. For example, replacing incandescent light bulbs with LED light bulbs does save money for companies and also has abatement potential. So that would be a win-win policy. Basically, there's no reason to not do that policy. And the problem is that incentives aren't strong enough for these kinds of policies because we can find them and discover them, but they're not actually being implemented at all or at a fast enough rate. As shown by this next graph, this graph models the balance between consumption and quality of the environment. In a perfect world, the areas beneath the curves represent all the ratios of consumption and environmental quality possible. Win-win policies expand the feasible frontier, as shown in the graph, because they add a segment where the slope is positive. The slope is positive because both consumption and environmental quality increases. A positive slope means that there are certain ways that you can there's certain ways that you can have a policy that does that, and then so the possibilities for what ratio of consumption and quality of environment we could have would be greater. The more win-win policies that we discover, the larger the feasible frontier becomes. And the ideal point on the feasible frontier would be some point between point D and point Z, because any point between point C and D are not optimal. Next, we have fairness. Thinking about the ethics of a policy determines how the policy should be written. And we also have effectiveness or efficiency, which is thinking about the cost or feasibility of employing a policy to determine how the policy should be written. Here's an example from the textbook. We have the polluter pays principle, which is to put a tax on an activity that causes some kind of pollution. A policy like this would reduce the profits of a person or a firm because you're taxing them, making them pay. A subsidy is where you grant money for switching to a different activity that reduces pollution. And so this would increase the profits of a person or a firm because you're giving them money for doing something. And so to decide what kind of policy we should employ, we need to look at the situation. In this example, we have a large city in a country where people still rely on wood fuel to, cook and provide heat. And so you could argue that the polluter pays policy would be unfair because the goal isn't to tax the poor families that have to rely on wood fuel, which does pollute the environment. And a subsidy would be more fair because you're really giving the poor people a chance to use a different kind of fuel, and also you are not taking away their money. And a subsidy would be more effective as well because it would cost less money to enforce the policy. Think about enforcing the polluter pays policy. You would have to find out how much pollution each person is doing, and then you would have to go to them and collect the tax from each individual household, which is way more work than giving a subsidy to just firms, basically, because the poor families won't really be able to be eligible for the subsidy. So this leads me to say that policies should be designed with fairness, effectiveness, and a clear objective in mind. So significance. What can we take away from the unit? Well, ultimately, the quality of the environment is a long-term issue, and this issue won't feel seriously damaging until decades into the future. However, abatement shouldn't be ignored because much of the environment degradation that we do will be very difficult to reverse. The unique fact that the environment itself cannot advocate for its preservation means that people today have to recognize the severity of the problem and do something about it. In addition, we have to get over the hurdle of scientific controversy and reach global consensus about what is and what isn't the case. And once we do that, then we'll be able to really enforce abatement policies and preserve the environment. That's it. Thanks for watching.